Hello everyone, my name is Praful Kumar and today we are working on a project that is Sobel Edge Detection using hardware software co-design. So I am working with my teammate that is Prathamesh Kadat. So this is the project workflow. So first we build a hardware software system to accelerate image processing using FPGA. So we are implementing Sobel Edge Detection solely on HPS and as well as HPS plus FPGA. So the filtering process will happen on the board. Actually it will happen on the hardware, that is FPGA part. So we are gonna then compare the results and infer what could possibly be the reason behind the timing. So this is the sub detection working. So let's say you have an image that is 512 cross 512. So what we do is we take 3 cross 3 pixel out of this image and then we store it in a memory using memory controller. So once that is done, so we have a kernel, predefined kernel, that is for x and y axis, so for that is for horizontal and vertical. So what we do is we multiply the matrix, this matrix, with these kernels, and then we calculate the grading and compute the total result out of this. So we have a threshold, we set a threshold that, let's say if it exceeds certain value, so that means the edge has been detected. So this threshold value is nothing but the sensitive of how intense the edge detected is. So this is the edge detected image here. So yeah, this is the working of Sobel edge detection algorithm. So this is the workflow. So while working only with HPS, we start and then we have a make file in which we have defined which exact .bmp file to pick from. And then once this is done, we run the code. In the code basically reads the image data, and what it does is after it reads the pixel data, so it's gonna pass it to the Sobel algorithm for edge detection. So once this algorithm detects each and every edge of the image, it's gonna send it to a function where reformatting happens. So once the edge has been detected, so it reformats the image back into .bmp file, and then we display the output image. So this is the entire workflow while working only with HPS. So this is how it's different from HPS plus hardware, HPS plus FPGA implementation. So we start the image, uh, like in the previous one we have the same make file, wherein we select which part of file we should be working on. So once that is done, so the pixel data is read in the HPS. So once the pixel data is read, it's going to send the data via on chip memory. So what we are doing is we are using axi interface. So via axi interface, it's going to send it to one of the on chip memory. So on DE1-SoC we have around 256 kilobytes of on chip memory. So we are utilizing some part of it, and then we are storing the pixel data, that is 3 cross 3 matrix, onto that memory via axi interface. And then what we are doing is we are basically sending the image. The hardware reads the image and then it processes the data onto the FPGA itself. So once the processing has been done, so we reformat the image back to .bmp file on the HPS, and then we display the output image, that is .bmp. So this is nothing but the working of HPS plus FPGA. So the Sobel edge detection happens on the FPGA, and the reading of the pixel data happens on the HPS. The code flow. So we basically load the images onto a variable, and then we iterate it from 0 to the total number of images. So this part is nothing but for collective images, that is for all four of the images. So we have a loop here running from 0 to 4, that is in our case, and then we are loading the file, allocating memory to it, and then we are basically processing the image using Sobel filtration for each of the loop, and then we are basically ending. So this is the CA and RTL code for HPS plus FPGA. So we are loading the images, and then we are basically reading the pixel data, allocating memory, sending the data to FPGA for the Verilog to read and process, and then the Verilog will give back the data back to the HPS, that is via X interface. So once the process data is received by HPS, we basically remake the .bmp file, and then we show that file. So this is nothing but the output of all the images. So if you could see, this edge has been detected for these. So here is execution time only on HPS. So we have different execution time for different images since they are of different resolution. So this is 512, this is 512, this is 512. So this takes around 0.36 second, 0.36 second, and this is taking around 26.78 second. So this execution time is when all of the images we run collectively. So it's taking around 82.3 seconds. So these are the execution times when running on HPS plus FPGA. So it takes around 31 seconds, and this takes around 0.43 second, this takes around 0.43 second. So this is the timing of each and every image on HPS and HPS plus FPGA. So as you can observe that these timings are a little bit higher than only on HPS, which is unexpected, since the reason behind this is because there could possibly be many reasons. So these are few of them. So it could possibly be due to poor utilization of FPGA resources, that is the ALUTs and stuff, and it also could be the delay between how we are transferring the data from HPS to FPGA. So so all these reasons could possibly be why the timing in HPS plus FPGA is more in this case.
Hello guys, welcome to the demonstration part of this final project. I am Prathamesh and I will be walking you through the demonstration of this project. So firstly we will look into the part 1, that is the HPS code running, and then the second part, which is the processing being done on the FPGA, and the HPS is required to just read the file and then to write the file. So as you can first of all, I will just show the how the FPGA board looks on a like on a diagram. So this is how it's gonna look like. This is the HPS part and this is the FPGA part. In part 1 we will be using the HPS. So here we will be detecting the image, that is the image is being given as an input, and then the Sobel function is being written over here. It's gonna read the image and then it's gonna write the output image over here. So and in the second part, the HPS, it's gonna detect the image. It's gonna take the input image, and then the FPGA, as you can see here, the Sobel function, it's gonna uh, compile the image, or it's gonna construct the image based on the edge detection scheme, and then it's gonna send the processed output to the HPS. Then the HPS will read that image and send it to the output. So this was the overview of the project, of the demonstration, and now I will show you the part 1 of this project. So as you can see, so in part 1 we will be dividing the project into two. So first one is like the HPS will read a single image and then it will give the output, and in the second one it will read all the images, that is a collective of all the images, and then it will give the input. So then we will see the execution time too. So for first, so so this is the C code for the image detection, and then the output for the HPS one. So as you can see, here is the Sobel function, which is gonna read the image, like a Sobel function to construct the image, and then we have the this function is gonna read the image, and then the Sobel function will be called in the main, and then it's gonna construct the image, and here the image will be written in the output. So this here we will be printing out the execution time too. So to do so, I'll just open this one. So as you can see here, this was a C code that I showed right now. Using this make file, I have created a different execution files for each of the images, and I have dumped this in the pen drive. Here you can see these are the execution files I have dumped here. Similarly, I have done for the continuation, like a collective of all the images. So this is the only one execution file, and here are the images. So we will be running the first part, and then we will be going to the second part. So let me open the putty again. Here I'll be using putty for the communication, or it's a replacement for the VGA operation on the HPS. Here is my putty screen. Here you can see this is the Linux display, the interface of the HPS. So as you can see, it has detected the pen drive over here. I'll just mount this one. So I mounted this. So basically, if I run the program over here, then it's gonna give me segmentation fault, as the memory is not being detected by the HPS. So I need to copy the pen drive folders to the HPS memory. So I'll be doing that one. So now I'll be copying the files, as I had already copied them, so I had to remove them. Now I'll be copying the files. So I copied the part 1. Now the collective images, as you can see here, part 1 and for the collective images, the files have been copied. So next we will go to the part 1 execution. So as you can see here, these are the execution files and these are the images. So first of all, I will run for the Batman. As you can see, it has taken the batmanjoker file, and then right now it is is constructing the image. The Sobel function is running. So here you can see it took 25 seconds to process this image. Now I will run for the board. It took only 30.36 seconds. So here you can see it took the board as the image. Then the last one is the Lena. So again here for it took like 0.36 seconds. So as I executed the Lena file, it took the Lena 512 as the image, and then it constructed the image using the Sobel function. So here it was for the individual images. Now I will show you for the collective one. As you can see, this is the execution file and these are the images. So first it took the Batman Joker file. It's gonna construct the image. So basically what it does is the Sobel function takes the image, then it detects the edge of the images and then produces a grayscale image. Yeah, here it took like 82 seconds. So for this I'll show you the C code. So what I've done is I have taken these images and then I have run a for loop, and for individual image execution I have calculated the time, start time over here, and then once the process has been done I have placed the end time. So for each execution I have calculated the time and I have added the overall time. So this overall time is being printed over here. So this is how I have calculated the execution time. So now we will copy this file to our pen drive and check like if we got the correct output or not. So we are done over here. Let's go and see like if it is being copied correctly or not. So here we can see that the files have been copied. Let us check like if the output images have been generated. So here you can see the boat out, Lena out, and then Batman Joker out. So the image has been copied. And let's see for the collective images. Yeah, it's been copied. So there was an issue when I copied the last file, so I'll copy this one more time so that the issue is not being persistent. So I'll unmount this one. So I unmounted it. So here you can see so this is the image it has generated. this is for the Lena one, and this is for the Batman Joker. Let's see for the collective one. So as I told earlier, like there was an issue with the copying. So I'll copy it one more time and then I'll execute it. So yeah, as it takes a lot of time to copy the collective images, so I did try my best, and then so here are the output images and it got copied finally. So yeah, and this one is for the board one, this one is for the Lena. So I did copy it for in the part 1 file folder itself instead of like out, wherein like I was getting the error, as you can see here. So this was all about the part 1. So to show the HPS board, um, so this is the HPS board, like the Cyclone 5 Terra 6 DE1-C board, which we are using for the project. So here this mini HDMI cable, like I have connected to to my laptop over here. So this is for the putty interface, and then this USB blaster cable, I'll be using it for the FPGA part. So further we will be seeing that one. So yeah, next we will be looking into the part 2. In part 2, the HPS is required to read the image and then to write the image. So basically it will take the image that is, like for example, like batmanjoker.bmp, it will take it as an input and then it will send it to the FPGA part. In FPGA there is a Verilog code, one to avoid the noise, and the second one to detect the images, like the edge of the images. So as the Sobel filter does in the HPS. So once it has been executed, so it will send the output image to the HPS, then the HPS writes the image out, and then we can see it on the file. So for that, first I'll show you the C code. So this is the C code for the HPS to read the image. As you can see here, we'll be giving the board or the Lena and the Batman Joker as the image, and then here it will just open the file and then read the image, and I have just printed the details of the image, like which image it is going to read, and then here it will just print out the image, like the output image information, and then the execution time. So as you can see here, we are not having any Sobel function. So as a Sobel function is going to be worked on the Verilog for the computation part. So now I'll open the Quarters Prime. So further I'll be explaining about the Verilog code. So in Verilog code, we have modified the like the previous project's GHRD top Verilog code. So it's like so the modifications which we made is like we have added the Sobel filter in this Verilog code, and then the connections which we have implemented in the platform designer. So as I'll be showing further, like I'll be copying those connections and I'll be adding them here. So this is the GHRD top, like this is the Verilog code, and we have modified this one. So as you can see here, um, so the main concerning thing within this code is like this one, the input row. So this is going to take the input row of the image, and then it's gonna give the output like for the pixels, the rows will be taken as the input row and it will be given as output row. And then there is a valid flag. So what does this valid flag do is like once we have uh, dumped this SOF file into the board, and then when we run the C code or like the execution file on the HPS, so the HPS will send one flag like the image is being like detected and then it needs to be like filtered. So that flag is being detected by this valid flag. So once this flag detects that on the image is being sent by the HPS, it tries to read the image and through the input row, and then it sends the output image like the output in through the output rows. So for this like these are the like temporary registers which we have created for the Sobel filter. So here is the, like the Sobel filter Verilog code. So this is like we have just implemented the same Sobel filtration which was done in C code. So this is how it works. So here are the temporary registers which we have created, like the output temp, the gradient, and then the temp gx and gy, like this is for the row horizontal and vertical detection. So this is how it works. And then comes the connections. So these are the connections which we copied from the platform designer. So, as we will be seeing further, like this is the input Sobel external connection, so this we have added, and rest of the connections we have just kept the same. So this is about the Verilog code. So this is the as you can see here, the QSys file. I have uploaded the QSys file, and then I have used the generate to generate the HDL. Once the HDL has been generated, then we will go to the quarters prime again, and then in processes we will do start compilation. It takes a lot of time to compile, so I already compiled this project, and once it's been compiled, the .so file will be generated. Then we need to go to the program device, and here in program device we need to detect the device which has been connected, as I told, like DE1-SoC DE1-SoC. So this is the this is connected to the blaster cable as I told before. So I need to check like if the file which I uploaded is correct or not. So yeah, the SOF file. So then we will start. So yeah, so it's been 100%, it's been dumped on the FPGA. So once this is done, as I've done previously for the HPS, I have loaded the file, the part 2 file in the pen drive, and now I will be placing the pen drive. So as you can see here, I have placed the pen drive on the Cyclone 5 board, the DE1-SoC board, and then the computation is going to take place now. So yeah, we are again back on the PuTTY screen. So first of all, I'll mount the external device, it's a pen drive. So once I mounted, I'll copy it to the in memory. So let's go to the folder. You can see the part 2 folder has been copied over here. Now let's open it. As you can see, as I told earlier, I have generated the different execution file by using the make file, and then these are the images. So I'll execute one of them. So let's start with Batman. So as you can see, it has taken the Batman as the file, image file, and then it is processing by the FPGA, and let's wait for the computation. Here the computation is being done by the FPGA instead of the HPS. So yeah, as you can see, it took 31 seconds, wherein earlier through HPS, I can go back, I think so. Yeah, in HPS it took 25 seconds. So, and here it took 31 seconds. Now let us compile board. For the board it took 43 seconds, wherein earlier on the HPS, okay, here on HPS it took, it's like board here, yeah, it took 30.36 seconds, and here it took, sorry, my bad, here it took 0.43 seconds. So let's compute for the Lena. Yeah, earlier, for Lena it took 0.36 seconds, and then here it is going to take 0.43 seconds. So as you can see, the FPGA is gonna take a bit of time for the computation part compared to the HPS. As done previously for the HPS, I'll do the same thing for this HPS to FPGA. Like I'll copy the file like the executed files, and then I will check like if it's correct or not. So 20. USB drive, and here out. So let's go and check here. Yeah, we have the part being copied over here. As you can see, yeah, the out images are being copied over here. Oh wait, yeah, the out images are being copied over here. Now let's unmount this and then check on my laptop. Okay, yeah. Going back here, the out part 2. Here you can see the out for the board. Yeah, wait a minute. So this one is for the board, and then this one is for the Lena, then this one is for the Batman Joker. That's it. This was all about the final project. I hope you all enjoyed. Thank you for watching.